Welcome, everyone. This talk is entitled Cloud Engineering Generation DevSecOps, and I am your host. I am currently the CISO of North America here at Checkmarks. I'm in InfoSec and AppSec today, but it's by happenstance and by way of engineering. So I have been an engineer my entire career. I still consider myself to be. Doesn't matter what my title is or what company I work for. I still write code. I write it because I enjoy it, not because I get paid to anymore, which is kind of fun. And I've been a developer and a development leader. I've practiced all of the methodologies, and I pivoted into that kind of AppSec space, and half of my career now has been spent in application security. Recently, I ran application security for the Bank of Montreal. I was responsible for securing thousands of applications that were created and built by or for the bank. And to talk about web application experience, my first product was in the storage management space. It was an intranet product, so it sat behind the firewall, like some applications are today. Way back in 1996, this is the primordial ooze of applications that were built with a web interface. In fact, for those of you that didn't know, in the early days, you had to pay for your browser. So my first day at a company called High Ground, I got to my desk and there were two shrink wrap boxes, one for Netscape Navigator and one for Internet Explorer. It's like, you cannot believe how that technology has advanced. DevOps and DevOps teams. This is a topic. So I've spoken at AppSec conferences, InfoSec conferences, development conferences. I've done, kind of agile type things as well. The conversation, and certainly being in companies proper, like at the bank, where people talked about what DevOps means. What is DevOps? Oftentimes people think of DevOps and think of the DevOps team as the people that build the scaffolding. I'm going to write some scripts. I'm going to help you create your pipelines. I'm going to create that kind of paved road for how we build and deploy software, but they're not part of a team. They're a separate team all their own, which is interesting. Feels very much like IT, feels very much like the old operations type concept. And for me, and for some in the DevOps community, thinking about DevOps is about feedback to the people that write and run the software. So I fully buy into the Amazon model of you write it, you run it. If you write software and then never have to deal with the consequences, how much time and effort do you think you put into those things? And it's just a practical thing. A, you don't know what you don't know, but B, that's not what you get paid to do. So if you're not responsible to operate the software, then if there are some problems with it, that maybe some people get woken up in the middle of the night, or they have to write some processes around it to say, oh, well, this runs out of memory every 3 days, so let's knock it over every 2. Those kind of things are typical. But if the team that writes the software has to be woken up, if the team that writes the software has to figure out how to make that stuff continue to run, then they're going to start to think differently about how they write it, because they don't want to be woken up in the middle of the night. So again, it's that living with the pain of what you've done, living with the consequences of what you've written, is, I think, essential to a fully mature DevOps program. It's not about an individual team. It's about every team. It's about the entire company. Further, if you think about the implications there, if I'm releasing software constantly, and let's say constantly was every day, well, how do we keep up with marketing? How do we keep up with support if we're not including them in conversations, if we're not helping them understand the pace of software delivery? How are they meant to sell it, to support it, etc.? Those things have to permeate the entire culture of the company. So talking about new releases, it's going to be a more frequent occurrence than they're used to. This is a talk and a concept that I came up with about 5-6 years ago at RSA. It dawned on me as I was looking at the way development was done that things were changing. And now I can tell you that things have changed in that way. The changes that I saw were around architecture. We had a product that was a monolith, and we'll talk a little bit more about what that means in a minute. We were breaking into microservices, so we were changing how we were building and deploying. Our team sizes were shrinking. We went from a model where the entire engineering organization was essentially one big team to having a fracture of dozens of teams. We were also changing our methodology on how we released software to say, well, we want to get to this DevOps thing. So it was new to us. It certainly wasn't new as DevOps has now seen its 10th anniversary, or at least the talk about what DevOps could mean. And the pace that we were being asked to deploy was ever increasing. So what that meant was we need to start looking for different people. We wanted to look for people that were lifelong learners and probably not people that were completely specialized. When I started engineering, it was not uncommon to have someone that was a DBA. They were experts. They knew the ins and outs of everything related to database. That is not the hiring profile that I saw coming, nor the one that I wanted to get to at that time. Furthermore, because the team sizes shrank, and we'll talk about that more in a minute, you can't have that specialization. You need to be cross-functional. And it brings up, especially as we start talking about cloud native technologies, what I'm now terming a continuous knowledge gap. So they talk about continuous everything with DevOps, and continuous knowledge gap is, I think, the next continuous thing. And we are being forced to change all the things all at once. So let's start with the architecture of the applications. Again, at that time, I was in charge of a monolithic product. It became brittle over time, the more code that was added to it. There were millions of lines of code in this thing. It was very complex, so adding new things. And if you think about when it was started, so it was started in, 10 years earlier, and now we're trying to add things that we never accounted for in the beginning. So you can think about how you try to shoehorn those things into a monolithic application. We had lots of technical debt. And this is something that isn't necessarily bad, but it is a fact. And of course, on the flip side, the product was making us money, which was great, which is why it was so big and so complex, because people needed it to do their work. So now, as we're being asked to break this into microservices, it's simple to understand. The picture looks pretty easy. I'm going to take the big thing. I'm going to break it into a whole bunch of little tiny things. Think like, maybe Lego blocks or something. And to do that is hard. You're taking pieces out that maybe weren't as neatly packaged as you might like in the monolith, and trying to figure out how to make those things work in a model that, from the user perspective, looks like it's the same application, even though it's a whole bunch of different processes. When you go to the Amazon homepage and do some shopping, there are literally dozens of microservices providing you pieces into that one application, if you will. That shopping application. There's one for the shopping cart. There's one for what's trending now. Here's what's on sale. Here's what's in your wish lists. Based on your current browsing, here's what you've looked at recently, those kind of things. All of those are completely separate applications that seamlessly integrate into what is your Amazon shopping experience. And that's really what this concept of microservices is. But when you're trying to go from something that does everything to something that essentially is a shell that collects everything, those are very different models. From a methodology standpoint, we started, of course, when I came into the marketplace as waterfall, and it was not uncommon to have 50 or more people on a team. And as I discussed before, that concept of DBA, we had tons of specialists. There were people that specialized in database code. There were people that specialized in the logic layer. There were people that specialized in the graphical interface, whether that was, your thick client Windows application, or now your thin client HTML type application. They specialized in that thing. And the release pace was slow, 1 to 4 releases a year. I mean, 4 was really doing well. 1 was more typical. And usually it ended up being, 14 months because you can never hit it right and accurately. Well, as we went to Agile, you're now shrinking from 50 people down to 6 to 12. So half dozen to a dozen people. And we're increasing the pace. What we want to do is to release every 2 to 6 weeks. So that ups the ante, and you have to think differently about how you do your work. With 6 to 12, there really isn't room for just someone that does DBA work or just someone that does quality. That doesn't exist anymore. I can't have that. I need these people to have cross specialization, to be cross functional, if you will, and more utilitarian. And of course, when we get to DevOps, the ideal here is to optimize around flow, picking up a piece of work, doing it till it's done, and releasing it to production. That doesn't necessarily mean releasing it to customer, which we can talk about. And there are lots of ways to think about how people do that, but it's to get it off your plate. Oh, sorry. It's about getting it off your plate. So there is zero specialization here. You have to be able to take the whole feature from stem to stern and pick it up, do it until it's done, and then release it. So how is that stretching us specifically today in these last 3 to 5 years around cloud development? The first one is around open source. If you're not aware, the majority of the code that you ship today in applications is open source. And by majority, I mean like 80 to 95% of your application is actually open source code. Developers take it, they stitch it together, and they sprinkle on those pieces that are the feature and function that you sell to your customer. Think of it like building materials, 2x4s and drywall and windows. It could have the same set of materials make many different kinds of houses that look very different. And that's essentially what the open source is. It's those raw building materials that you make into those structures through craft. The problem again in here is that developers integrate and abandon these things. Once I found something that does what I need, let's say it's crypto, I'm going to insert it, I'm going to integrate it, and then I don't think about it again because it's done. And I got to move on to other things because of what I'm being asked to do. That means the technical debt piles up, bug fixes aren't incorporated. If there's a security vulnerability, I have to go back and figure out how to upgrade it, which is non-trivial sometimes. Second area is around API development. Around that time, people were looking at integrations as the path forward for development, especially as you think about DevOps and the automate everything movement. When you think about an application that does something for or to your company, so if I'm building something, let's say software security testing, when I think about what that does it require a person to sit at an interface with a mouse and poke at buttons and say, hey, upload my application and test my application and look at the results and then take those and move those into bug tracking? By providing an API layer between the interface and the product itself, it allows us to put anything on top of that functionality, whether it be a mobile interface, a thick client interface, some automation, like maybe automated testing, or to allow us to run the entire application headless, which is what a lot of companies want to do. So I want to scan, but what I'm going to do is I'm going to have a computer say, okay, here's how I package it, here's how I upload it. Then I'm going to go get those results and I'm going to incorporate them into my bug tracking system, all via computer. So APIs are critical. The problem here is that securing those APIs is difficult. And the vendor community is still trying to mature the tooling around getting API security testable in a meaningful way. And there are a number of ways that people do it currently that are okay, but the future is really to automate that with tooling that's specifically designed around application API security. The third area, and probably the hardest one to do right, is around infrastructure as code. When I started development, people had their own infrastructure. it was physical. It resided in a building with air conditioning. There were racks of computers that people would go into a room and they would go and do stuff. So it was rack it, stack it, cable it, install software on it, harden it. If there were problems, then I'd go into the computer room and investigate and figure it out. And there were keyboards and monitors in there for me to get access to those things. Today, it's become part of the application landscape. Developers are creating this thing from configuration. So if you think about AWS and Google and Microsoft, I am creating computers from nothing. I've got a text file that says I need to have a CPU that's this big with this much RAM and this much disk and this kind of network, etc. And then magically a computer appears. In the old days, it was weeks or months for you to get the hardware shipped to you, and then you got to bring it to your production facility, et cetera, et cetera. Now it can happen in seconds, and it happens through code. Developers were never, ever taught how to do this stuff. So this idea of containerization and serverless and how to create infrastructure from scratch and what the output of that is, because it's very easy to do it insecurely. And a lot of the vendors, especially initially, said, hey, it's just a computer, so go nuts. So it was easy to do, but it was always insecure by default. So how do you do that in a way that allows you to create secure infrastructure and have it be the responsibility of these people that were never trained on it? The concept of cattle versus pets. I could lovingly handcraft a machine, and I've put together computers from pieces before, certainly not at the enterprise level, but I know how to build a computer or build a thing. That loving handcrafting is interesting, but only in the small. If I need one or two of those and I really want them to be specialized, maybe that makes sense. But when we're talking about creating infrastructure for applications that might need thousands of instances, how are these two people going to possibly be able to do that at speed and at scale? And what if something goes wrong? So the way that things are done today, this infrastructure as code shifts it left to say that I'm not creating the computer, but I'm writing the script for the software that creates the computer. And this is kind of like the CNC version of production, where I say, here are the instructions to build a computer. Computer reads that and says, okay, here's a computer. So we need to get away from this idea of pets and get to the idea of cattle, where I can quickly repave the road with a fix or with an upgrade or an update, or if there's a problem, and I can create hundreds of thousands of them very easily and very reliably. Of course, we have this idea of continuous everything. If you think about DevOps, with these cloud technologies, they are constantly changing and evolving. Serverless is not the last frontier. I don't know what the next one's going to be. I can't, claim to know that, but I know that looking backwards, that all of these things change, and they change at a fast rate, especially if we want to do this securely. So this idea that security is a first-class citizen now means that we've opened up this continuous knowledge gap. So if we go back to that infrastructure as code example, boy, thinking about which container to pick and which ports need to be opened and which software should be uninstalled or disabled. How do I do all that stuff? That is a knowledge gap that I have. So it requires us to be lifelong learners and to have continuous learning as part of our process. So let's look a little bit closely at organizationally and process-wise how software was and is built. And some of this still happens today. I've seen instances of it in large enterprises that are frankly struggling to change. In the legacy sense, the developer built the software, and this is what I did. And when I finished coding, I was done. You chuck it over the wall to the quality people, and they test it. Now, of course, if they find a problem, comes back to me, then goes back to them, and that can happen multiple times. Then we pass it along to security when we think we've got it all tightened up. Then we go to people. So we have to schedule a meeting. There are multiple executives in there, what they call the change board or the cab, where I say, hey, I want to make a change in production. Here's what we're going to do. Here's when we want to do it. They'll approve it based upon the evidence that we provide them that we did all the due diligence prior to that. Meanwhile, inside of those production environments, again, the racking, stacking, and cabling happens by systems people that set up the hardware. Then the IT people come in and they install the base operating system. They would install things like JBoss and Tomcat on top of that, that provide, you know, the support and structure software for our application. And then operations would install that application and monitor it to make sure it's working over time. And this is the siloed model. This is the way companies had been organized and to some degree still are and still struggle with. Those handoffs and people in these processes slow everything down. If we look at cloud native software development, as an individual now, I'm going to build a feature. It is well understood now that I am also responsible to test it. The concept in Agile is called the definition of done, which means when you pick up a piece of work, when can you declare victory? When do you say mission accomplished? And to some degree now, it implicitly includes the fact that it has to function, but that wasn't always the case. Now we want to increase that definition of done to include security. So does it pass muster for whatever level of security is required by my business? And by the way, even inside of a business, the security requirements are different for different applications, depending on the risk profile of that app. Now, instead of people, I codify the rules into pipelines. So the CI portion of the pipeline takes a look at whether these features can be pushed along and moved through towards a release based upon previous testing. So these are kind of your, what we would term as assurance scans. Then I would have software as part of that process that terraforms the environment, creates those computers, does that infrastructure as code, sews everything together, installs and configures all the supporting software. Then I would put the application on top, and my team would be responsible to monitor it over time. So this is the classic DevOps. You write it, you run it, 2 pizza teams, 6 to 12 people. These are the people that monitor and manage the application because they require that feedback to do their job well. So this is the major change in development. And I can tell you that there are not a lot of instances where this is done all the way. If you ask people in your company, well, where's our DevOps team? It's this isolated IT type operations team that builds, supporting and enabling software, not teams that deliver product. For me, DevOps is about the teams that deliver the product. So this now leads us to this continuous knowledge gap and this idea of a cloud engineer. The cloud engineer is responsible for all of the things. They're responsible in that previous picture for testing it, etc. So if we take a look at each individual component of this, first of all, I need to be a great engineer. I take great pride in the software that I write. It does mean that there's a bit of a hamster wheel for me to keep up with all of the happenings. Some of it's new languages. The rate at which new languages are created is incredible. The changes in architecture and deployment models, in implementation styles. This idea of cloud native, again, if we think about cloud native, well, what exactly does that mean? Does that mean I'm going to write for Amazon or I'm going to write for Microsoft? Or does that mean I'm going to be hybrid and I'm going to be cloud agnostic where I can deploy into any? Those have specific ramifications in what you can program to and what you can't. And this is one of those things that you see repeated again and again over time, where you look at when I was doing Windows thick client interfaces and people were trying to build these multi-client, these GUI agnostic tools that could run on OS2 and Macintosh and Windows. Those had limitations. there was power in that you could write it once and run it everywhere, but also there were consequences of you write it once and you debug it everywhere because it doesn't quite work the way you want it to everywhere. I need to be in charge of quality as a teammate. When I pick up a piece of work, I have to build it in from the beginning, or I have to think about building it in from the beginning. If you have a high level of maturity around quality, then you're doing TDD, or test-driven development. You write the tests first to prove that it works, and when all the tests pass, you're done. That also means that I'm writing unit tests. I'm writing some regression tests to make sure that things that I fix don't re-break other things. There's a lot of work and expertise involved in being a great tester, which doesn't mean that you can't have specialists in your company. I just wouldn't put them all on individual teams. And then the question is around, well, how are we testing? Are we testing with production data? Or do we have synthetic data that we can create to make that real? And those are important distinctions to make and have some ramifications around your ability to test for real. The deployment, the infrastructure as code, understanding containerization or serverless, making things automated and repeatable, being able to do it on demand. Having that kind of paved road where if I find a problem in production, maybe I'm allowed to go SSH into a device and look at it and figure out what's going on. What would be ideal is I have telemetry that gives me the information I need. But once I figure out what the problem was, I don't fix it there, because not only is that not the right thing to do because it should be immutable, but also I may have tens or hundreds of instances of that exact configuration that I want to modify. I got to go shift left back to the code, make a modification in the configuration script, and then repave the road, have it all done again, knock it over and build it back. I need to keep it running. So we talked a little bit about that with the infrastructure portion, but this idea of telemetry, this idea of how do I debug, how do I fix, how do I make my code anti-fragile, how do I make my application resistant to failure? Those things are critical in operational capabilities. By living this pain, by living and understanding the fact that it's hard to test in a real world environment, so you will miss things of scale, of performance, of load that only exist in your production environment because it's just not possible to recreate, or it's too costly to recreate. So having the right infrastructure and the right mindset around operationalizing your software is important. And by living that pain, you become a better developer and a better development team. Lastly, it's around security. If security isn't currently part of your definition of done, then you should be talking to your company about it. Now, maybe security is important to your company, but I would argue that since you guys are sitting here watching this talk, that it is to your company. It's not true for everybody. Not everyone has the same level of security requirements. Certainly, I worked at a bank, very high bar, healthcare, the same, retail, similar. But there are other companies or even other applications in the bank that weren't thought about, that didn't need to be as secure as those. Some of that was marketecture, telling customers about the banking products that we had, and those sites, we don't want them to be defaced, but there's no like PII or company confidential information that's held in there. So the level of security scrutiny that was placed on each of those was very different. This idea of shifting it left, of finding and fixing it early, understanding the costs that you bear when you find things late in the process, is something that we're relearning. We learned it with quality, which is why test-driven development started to happen. We're relearning it with security. We shouldn't wait until the cake's fully baked to find out that we didn't add, the right amount of sugar or the right number of eggs to be able to have to go back in there and unbake the cake to make that happen. So that those things are just hard, in some cases impossible. So why do that? So we look at the amount of rework that's incurred by our security scanning, and then we try to make adjustments for that. So as security professionals and as development professionals that want to lean into security, how do we do this? And I've been talking about this for a very long time now. The number one thing that you need to have is you need to have a relationship. It's not those security people or those developers. Do you know a name? Is it, Tom, Mary, George, whatever? They are there to help in both instances. So the developers write it. They're the ones that have to secure it. We don't want this to be an us versus them. We want it to be a we. Back in my first startup, the VP of engineering, we would be in meetings with him, and these meetings would get heated. We all had very strong beliefs and very strong ideas. Oftentimes, he would bring the room to silence and say, "Look, everyone, pull out your business card. Take a look in the top left hand corner. What does it say?" Guess what? It doesn't say, GUI and middleware and IT and quality. It says high ground. We're all on the same team. We all should be headed towards the same goal. The enemy is outside, not inside. So let's act that way. So by building these relationships, it allows us to have these conversations about how we get better together. Secondly, is about learning the craft. And this happens on both sides of that equation. Security professionals look and say, well, if you just did that, if you just did this, everything would work better and I wouldn't have to come and yell at you. Well, the fact is that development is both a science and an art. People take great pride in their work, as do the security professionals, but we don't really pay a lot of attention to the problems that each of us have and the challenges that we face in schedule, in implementation, in remediation. Those things are hard. And until we understand them, then we don't know that we're providing help that helps, if that makes sense. So we cannot remain ignorant around how the software is built and those kind of challenges that developers face. We need to be there with them in the trenches, understanding that pain and coming up with solutions that actually work. Third is about accountability. Now, you've noticed I haven't said anything about tooling, and we're going to get to that. But really, this is a people, process, and technology problem. All three legs need to be accounted for. This one is incredibly important. In fact, if you don't have this, then it's always going to be a fight, whether or not you have those relationships, whether or not you understand how things are done. Without mutual accountability, in other words, we're all aimed at the same goal. We're tugging on the same side of the rope. If we're not trying to get to the same place, then our actions are not going to be in alignment. In the classic sense, operations people are paid to keep production glassy smooth. I want the customer experience to be awesome. I never want downtime, etc. But the engineer is paid to make constant change. Those things are not in alignment. You can't even drop a pebble into a huge glassy surfaced lake without it causing ripples. It is a consequence of change. So having goals that say you can never have anything besides glassy smoothness, and I'm going to be mad at you if it's not, and you hurry up and change all the things, those things are going to remain in conflict. You have to align those to something that's more practical, such that the operations and development people could be tugging in the same direction of saying, hey, what do we think about our production experience and our customer experience, and how do we work together to get there? There's a story back in the space program where Kennedy was at NASA walking the halls trying to understand the moon program, and stopped a person carrying a broom and said, hey, what's your job here? And he said, I'm here to get a man on the moon. And his actual job was, he was a janitor. It shows you the kind of goal alignment that was required to accomplish what seemed to be the impossible of getting a man on the moon and getting him back again. Where all the way down to the person that emptied the trash cans and swept the floors and cleaned things was in alignment, that his mission essentially was man on the moon. Anything short of that was failure. So think about that in your company. How do you align your goals in such a radical way that you can bake it into the annual goals. You can measure and report on it. You can pay people for it. If they're not paid to do something, then they're just frankly not going to do it. And I've seen this happen so many times. Um, security professionals would come to me after the talk and say, hey, I can't get my Agile team to take in any of my security stories. And frankly, the answer is, well, guess what? They're not gold on security. They're gold on shipping product fast. It's your problem to figure out how to do security from their perspective. So obviously they're not going to do that. And maybe security isn't important enough to your company. So think about that and think about changing those goals, because it will open up doors that were not able to be opened previously. All right, we're finally into tooling. We need to know where we're deficient. We need to know what good enough looks like. We need it to be fast. We need it to be accurate. I need it to be integrated into the tooling that I use today and the tooling I may use in the future. I need to be able to automate it, because this idea of DevOps, this idea of releasing things when they're done, can only happen when the tool chain is automated. So bring your development teams together with security to talk about what tooling would work and why. Kick the tires together. If you make them part of the process and you make them feel like they were heard in the requirements portion and POCs about, hey, this will work for us, this is great, or wow, this really won't work, because you won't make mistakes farther down the road. Lastly, it's about training. And this isn't the big bang, annual, here's 8 hours worth of training that you need to go take, which is mind-numbingly boring. People click through it and then pray that they can pass the test at the end. This is about micro training. If you have the right tools, then you should be able to use the output of those tools to inform an education program. The goal, I would argue, of your application security program should be for developers not to make mistakes in the first place. Now, of course, we can't start there. We got a brownfield, so let's use the tools, figure out what's going on, talk to them about it, and help them understand how what they did was insecure, what the consequences of that are, how to fix it, and even better, how to prevent it in the future. How do I get there into such a place where it's not going to be a problem? The tool won't pick it up because I didn't code it the wrong way. Also, I love to make this personal. If you are in a healthcare industry, let's say you're in a place that creates implantable devices. Well, the people that develop the software that goes into those embedded devices, do they consider this a problem of the customer, or do they think about the potential of them having one of those devices implanted in them, or their parents, or their children? If you can get it to that point where you really get the fact that this is connected to you. If you're at a bank, oftentimes those employees use that bank as well. You're protecting your own money and those of your family. In Boeing, they actually put some of the engineers on the plane when it's going through its first test to say, hey, how sure are you that this stuff works? If you're so sure, then get on the plane and let's go take it for a ride. So think about that. If you make it personal, then they will take it more seriously and you will have their attention. So in conclusion, I want to tell you that software and the way it's built, the way it's deployed, it's changed. I've seen that change personally, and it's going to continue. The rate of change will not slow. The team sizes are not going to get bigger. There's lots of evidence, if you look at books like Accelerate, that look at the consequences and the advances that DevOps and Agile have given us. We're not going to go back to those 50-person teams. So we need to figure out how to make that team size work. There's no company on the planet that's going to say, hey, that's fast enough. You guys are doing great. Take the rest of the day off. We're going to keep pushing for getting faster, which is going to drive some of the technological advancement. And we need that accountability. I really urge you, if there's one thing you take away from this talk, think about that mutual accountability. So from our engineering perspective, build those cloud engineers, help them fill in those gaps where maybe they didn't have experience in building out infrastructure, or they don't have experience in software security. I can tell you that when I graduated with my Bachelor of Science in Computer Science, no one ever talked to me about security. So the workforce is untrained and continues to be untrained. So we have to build it. Cross training your team members is essential. They can't just have one specialty and one job. Again, think about that flow. Optimizing for flow means that they need to be able to do all the jobs credibly, which means you back it up with smart computers and tooling that can measure whether or not they've actually accomplished that. So we need those tools there to do it. And think about changing your hiring profiles. Are you hiring people that are continuous learners? Are you hiring people that have that T-shape, or that full spectrum engineer, as I used to call it? Do you have that? So that's the profile that I would urge you to look for when you're hiring people. And that's not just in development, but it's in security as well. Thank you very much for your attention. I'm going to stop screen sharing, but I am happy to take any and all questions from you at this point. So please jump into the chat, and I'm happy to stay here for the next 10 to 15 minutes and talk to you about what you've seen. You can come off mute if you'd like, come on camera, and we could chat about the talk, what you found interesting, maybe what you thought was BS and you don't agree with. I'm happy for any and all of those comments. Okay, I got a question here. How long did it take for you to get comfortable knowing your program code? What did you do to get better at program code? Josh, do you mind coming off mute and giving me a little more information and background on that question?
Yes. And hello, by the way.
Hi.
Yes. So I know I want to get into the definitely I want to get into the cloud security industry. I started 2 years ago getting into cybersecurity. I find it very, very interesting. And I notice if you want to specialize, getting into cloud security, you have to know some type of programming. So that's why I was asking you that question. How long did it take you to get comfortable with programming, knowing how to code, and what did you do?
So are you coming at this from, you want to be a cloud engineer, or you want to be on the InfoSec side of helping secure the cloud implementations?
Helping secure.
Okay. So I would argue that you don't necessarily need to know how to code. If you look at what it takes to create a great application security program, to create those great outcomes, there are many opportunities in there for you from a specialization point of view. So think it's different from the team perspective of a team picking up and doing work. There are aspects of this of training. So are you great at talking to people and explaining problems? In remediation, so when teams are struggling with it, can you come in and help them understand how to change their code or change their implementation to do that? So that's a place where, yes, you would need to know coding. To build a great AppSec program, I think also requires you to really be good at, as a company, at threat modeling. There's a place where you don't need to understand coding at all. You need to understand the concepts, the flow of data, the process, the trust boundaries, those kind of things, and the implications of cloud native versus hybrid cloud versus your own infrastructure. Those are places where you could absolutely dive in deep into security about what are we afraid of, what could possibly go wrong, and how do we put the right controls in place to do that. So there are so many places inside of InfoSec, inside of AppSec proper that you don't have to code. If you want to, then I would think about that remediation side and maybe that training side as places for you to go and to start learning by doing. OWASP has a lot of resources around insecure code that they have available that you can go in and start fixing and remediating on your own, running it through the various scanners to see if you've done it properly. So if you want to dive into coding, start coding. If you want to be part of that cloud infrastructure and understanding, so for instance, is your company going to focus on one cloud provider, or are they going to be cloud agnostic? There's so much more that you need to learn in both of those cases to dive down the right rat hole to get the information that you need to do those kind of threat modeling exercises, et cetera. Or, maybe you're a pen tester. That's another place from an application security perspective that is absolutely essential. Maybe someone that runs dynamic scans, or maybe some hybrid, that kind of DAST informed pen test, or a threat model informed pen test where you look at the increments and what was changed and how am I going to attack that. So there are so many areas that you could dive into, and I'd be happy if you want to connect to me over LinkedIn. We can further that chat.
Oh yes, please. Yes.
All right.
Yeah,
So go ahead.
Just that by itself, I have so many questions.
Okay. All right. Happy to dive into those a little bit deeper. So
yes,
the next question is from Mike. How do you implement separation of duties? Oh, that's a great question. Mike, for me, and I'm happy for you to come off mute and challenge me on this. Some of this, and again, this is part of the, if you think about the people that write it and the people that deploy it being different, in my mind, because it's codified in code that's checked in, that has multiple eyes on it, that is inherently a separation of duty, provided that your pipelines are secured and people can't jump the process and put things in production outside of that process, outside of those pipelines. I consider that to be partially that separation of duty. So it is a way of interpreting the intent of separation of duties versus making it hard and fast, like you have to have a different person doing this than the fact that what are we trying to account for? What is the threat? What are we afraid of? That's the essence of what I want to get at with that, which is why, your infrastructure is code and your CI/CD pipelines are codified, checked in. You could even have security as part of that process to look at those and audit those change logs to validate that the right changes are being made and that we have the policies codified properly. Does that make sense?
Yeah. So you were talking about there is a separate review before it goes into production.
In the legacy sense, you would have a change board,
right?
But what I'm going to argue with you is that the evidence you provide is seldom understood by the people that are making those decisions. These become places that look like there is a separation of duties because you have to go ask somebody else and then they have to give you a yes or no answer. But more often than not, they say, yeah, this looks good. Okay. Whereas if you have computers that do more rigorous checking, so if you think about codifying your policies, my unit tests, my security tests, and those kind of things where I know what the policy bar is. I have software that can measure it well and to say you either pass or you do not. If you do not, then you cannot. Whereas if you clear the bar, then yes, please proceed to production. So the more of those things you put into code, the more they're done diligently, reliably, quickly, accurately. And it's not, some person going, yeah, okay, I'll let you release today because your evidence looks overwhelming. There's just too much of it, and it's happening too fast. And if you want to get to the pace of DevOps, you can't have people in that.
Yeah, well, the problem I think we come across is, and I work on a federal contract, we're held to NIST standards, and I don't think the standards have really caught up to this.
I agree.
We're still looking at the old waterfall method.
Yeah, and in the federal space, there is certainly work being done around DevOps in leaning that forward at this continuous, this license to continually operate, based upon the codification of those tests where you kind of get this blanket permission to go do things. But you're right, the standards aren't there. The diligence and the audit tracking, the evidence collection and the review of those, until we start to figure out that, maybe those things aren't perfect. They're certainly not perfect. We understand that, but how do we make them better so that they can at least be done more repeatably? Even if they're done repeatably wrong, we can improve that over time. We won't get to this place where we can release this software more quickly.
Okay, well, thanks.
All right, last questions around check marks. Excellent, I get to talk about check marks. How does check marks adequately assess infrastructure code? The answer is yes. There is actually an open source project called KICS, K-I-C-S, which reviews and scans your infrastructure as code. It is 100% free, and you can go in there and start to assess that infrastructure as code to understand whether the output of that code will yield secure infrastructure. And it's a place where we invite the community to come in and help us expand upon the depth of those scans, broaden it out into other newer technologies. But yes, that's how we do that. And we've shared it with the community because we believe it's wicked important.
What was that? What was the name of that again?
KICS, K-I-C-S.
K-I-C-S.
So it's an open source project. And if you go to checkmarks.com, there'll be pointers to that as well. Does anyone else have any questions? All right. Well, I thank you all very much for your time. I hope you enjoy the rest of the conference, and feel free to hook up with me on LinkedIn, follow me on Twitter, or otherwise connect, and I'd be happy to have deeper conversations around application security or development in general. Thank you.